There are a couple of different options for starting a new part in Solidworks. Up at the top of the interface, I'll click on the Solidworks welcome icon shaped like a house. You might see this as the startup window when you first open Solidworks. From here, you have the option to create a part, assembly, or drawing file. These are the three main file types in Solidworks. You can also access the new file options from the new document icon in the toolbar. Just like in other Windows-based applications, Solidworks has a file drop-down menu. To show this menu, just hover over the Solidworks logo, and under File, you can start a new file from here as well. I'll click it, and you can see the new document window starts up again. If the new Solidworks document window looks slightly different on your screen, notice the Advanced button here. If I click on it, you can see the part, assembly, and drawing files as shown earlier, but you also have a couple of tabs up above, Templates and Tutorial. These files were included with my default installation of SolidWorks and are essentially different templates that you can use as the basis for new files. I won't delve too deeply into templates right now, but essentially, they contain certain options and settings that will be included when you create a brand new part file. I'll talk about that a little bit later, but for now, I'll click the Novice button to switch back to the Novice view. I'll go ahead and create a new part file by clicking on Part, and then OK. Throughout the remainder of this course, I'm going to be designing parts using metric units. The template that I'm using here is actually using units of inch, pound, second. An easy way to see which units you are in is by looking at this button here in the status bar. Every part you create in SolidWorks will begin with a 2D sketch. Notice, right now in the status bar, that I'm in Editing Part mode. There are two modes that we'll be working with, Editing Part mode and Editing Sketch mode. The status bar is a good way to know which of the two modes you are currently working in. Let's begin by creating a new sketch. One method in doing so is by simply clicking on the sketch icon located here in the sketch toolbar. I'll show you a couple of other methods a little later. When I click the new sketch icon, SolidWorks asks me to choose a plane on which to create a sketch for the part. So which sketch plane should I choose? Well, in the first lesson, we saw right away how two approaches could be used to create the exact same geometry. In one approach, a wide rectangle was sketched on the top plane and extruded up. And in the second approach, a thin rectangle was sketched on the front plane and extruded to create the width of the shape. Many SolidWorks parts can be created in multiple ways, so it's really up to you to choose the sketch plane that makes the most sense based on your design intent. For now, I'll choose the top plane. And when I do, notice how SolidWorks rotates the graphics area so that we're looking straight at the sketch. Or, to put it in SolidWorks terms, we're looking normal to the sketch. Notice in the status bar, SolidWorks now tells us that I'm editing Sketch 1, so I know that I'm in Edit Sketch mode. You can also tell we're in Edit Sketch mode from these couple icons that appear, which I'll go over a little later. If we look over at the Feature Manager tree, you can see that a new sketch was created, Sketch 1 in this case, and I'm essentially ready to start creating our 2D geometry. Before I do, I want to show you a couple other approaches of getting in and out of Edit Sketch mode. I'll first quickly sketch a few circles here. Once I've completed doing that, I'll click on the Exit Sketch button. When I do, you can see the sketch geometry as well as the sketch in the Feature Manager tree, and you can also see I'm back in Editing Part mode. Since I'm in Editing Part mode, I can't change any of the geometry that I created in the sketch. If I wanted to make changes to the sketch, I have to get back into Editing Sketch mode. To do this, I can click on the sketch from the feature tree and select Edit Sketch. Notice that I'm now editing Sketch 1, and the familiar sketch icons appear once more. At this point, I can modify the geometry or move it. And I can even add additional geometry if I wanted to. If I press the D key to bring confirmation corner to my cursor and select the Exit Sketch button once more, I'm back in Editing Part mode. I'll click again on the sketch and select Edit Sketch. I'll make a couple changes here. And I'll sketch one more rectangle. We saw how exiting the sketch with this icon puts us back into Editing Part mode and saves all the changes that we made. This red X icon, the cancel icon, will discard any changes that we just made. Be careful of this. If I click on the red X, now SolidWorks prompts me that the sketch will revert to the state it was in before I started editing it. Let's see what happens here when I click it. I'll click Discard Changes and Exit, and you can see the sketch reverted back to the state it was in before I edited the sketch. Now that you're a bit more familiar with how to get in and out of editing Sketch, let me show you one other approach for creating new sketches. In the first approach, I used the New Sketch icon, but I'd like to show you one shortcut that experienced SolidWorks users often use to save time. When I used the New Sketch icon, SolidWorks prompted me to choose which plane I was going to sketch on. There's actually a shortcut to doing this in just a single click. Now, I had originally created the first sketch on the top plane. What if I wanted to create a sketch on the front plane? Well, I could select the New Sketch icon and then choose the front plane. But since I already know I'm going to sketch on the front plane, I can simply click on the front plane from the feature tree, and from the context toolbar that appears above my cursor, Now that we've talked a little bit about how to start a part, how to start a sketch, and how to choose the sketch plane, I'd like to quickly go over a few of the sketch tools that we'll be working with throughout the course, beginning with the line tool. The line tool can be activated from the sketch toolbar. I'll enable it, and when I do, you can see in the graphics area that the cursor now appears as a pencil with a line next to it, meaning that we are in Insert Line mode. With the line tools active, I'll click anywhere to start sketching the line. I'll click and release the mouse to sketch the first point, and click again for the end point. When I move my cursor, you can see that Solidworks is actually creating a chain of lines. This is convenient because oftentimes you want to create a complete chain of lines to eventually make up a closed profile. Once I click on the last endpoint, you can see the chain of lines is closed. Notice that by default, closed sketch contours like the shape you see here are shaded. This makes it easy to click and drag the shaded area to move the geometry. You can always turn this functionality on and off by going to the Tools drop-down menu, and under Sketch Settings, select Shaded Sketch Contours. I'll deactivate it. And now, if I try to click and drag the sketch entities, notice I can't. I'll activate it again, this time by right-clicking anywhere in the graphics area, and under Recent Commands, I'll select Shaded Sketch Contours. If I click again to start a new chain of lines, I can end this chain by double-clicking. Alternatively, I can end the chain by right-clicking, and you can see End Chain here in the right-click menu with double-click in parentheses. Anytime there's a shortcut, Solidworks will display it in the parentheses as you see here. So I'll click End Chain to end the chain of lines. Notice that as I created these first few chains, I began by clicking once, clicking again for the endpoint, and then clicking each endpoint and continuing. However, if you just want to create a single line, there's another way I could do this. Let me end this chain of lines by double-clicking. Now, instead of clicking and releasing, this time, I'll click and hold down the mouse button and release it to create the next endpoint. When I do, you can see Solidworks didn't create a chain of lines this time. It just created a single line segment. So, to sum up, using the click-click method, I can create a chain of lines while using double-click to end the chain. Or, I can click and hold the mouse button down to create just one line segment. Now let's get rid of all this geometry. To do this, all you have to do is select it and press Delete on the keyboard. However, notice that since the pointer is showing the pencil with the line next to it, Solidworks is telling me that the line tool is still active. In order to select geometry, I need to get back to my selection arrow. I can do this by hitting Escape on my keyboard, and I'm back to the selection arrow. The reason I point this out is that it can be easy to forget that you're still in sketchline mode. And when you go to select geometry, you end up creating these little line segments instead of deleting the selected geometry. I'll press Escape again to get back to the selection arrow. And to delete geometry, all I have to do is select it and press Delete on the keyboard. I can also select multiple entities by holding down the Control key, and you can see each of the items are highlighted. With all three of these items highlighted, I can press Delete on the keyboard, and Solidworks will delete all of them. Another convenient way to select multiple line segments is to use a box selection. All I have to do here is click anywhere in the graphics window and drag to create a box. Anything that's completely inside the box is going to be highlighted when I release the mouse button. And I can press Delete on the keyboard. Notice that when I select from left to right, Solidworks is only going to include items that are completely inside of the selection window. If you've used AutoCAD in the past, this is very similar. When I release the mouse button, only these two lines are highlighted because they were the only two that were completely inside of the box. Let me press the Escape key to clear the selections. Alternatively, if I click and drag a box from right to left, anything that is touching this rectangle will be highlighted, so I can press Delete on the keyboard to delete these. To get back to a clean sketch, I'll just box select the rest of the lines and press Delete. Next, let's quickly go over the rectangle tool. Notice next to the icon on the toolbar, there's actually a drop-down menu. There are quite a few different types of rectangles, but I'll only talk about the corner rectangle and the center rectangle in this lesson. Let's start with the corner rectangle. With the corner rectangle selected, you can see a rectangle icon appear next to my cursor. The two white dots on each corner of the rectangle indicate that this is going to be a corner rectangle. This one is really straightforward, but as you work with other rectangle tools and other sketch tools for that matter, it may not be quite as clear which selections you're supposed to make. If I switch to the center rectangle, notice that the first point I'll be selecting is the center, and the second point will define the size. So I'll click once where I want the center to be, and click again to create the rest of the rectangle. In the previous lesson, we went over a couple of the basic sketch tools and touched on the idea of geometric relations. Since Solidworks is a parametric modeler, dimensions and relations are really what you're going to be using to control the shape and the size of the geometry. To show you what I mean, let me sketch a chain of lines here. Notice that when I start the line tool and bring my cursor close to the origin, a yellow flag appears. This flag is indicating that Solidworks is going to add a geometric relation, and in this case, the relationship is going to be added between an endpoint of the line and the origin of the part. If I click to start the line, notice that when I bring my cursor up close to vertical, Solidworks snaps the line to be vertical, and also brings up a small yellow flag indicating that a geometric relation is going to be added. I'll click to add the endpoint, and double-click to end the chain of lines. To show you what these geometric relations are doing, I'll hit Escape to get back to my selection arrow. Now at this point, the line was sketched vertically, and it actually added the vertical geometric relation. Also notice that the sketch turned black. Black geometry indicates that it's fully defined, while anything in blue is underdefined. So in this case, the line itself is black, but the endpoint is still blue, meaning that if I click on the blue endpoint, I can still move it. But I can't move it side to side, since there's a geometric relationship of vertical on this line segment. Let's continue with some more line segments. Up to this point, I've been showing you how to access the sketch tools from the sketch toolbar up here. But I'd like to get you in the habit of a slightly more efficient approach, which is using the shortcut toolbar. By pressing the S key on the keyboard, Solidworks will bring up many of the sketch tools for quick access, so you don't have to move your mouse all the way across the screen to access these commands. I'll click on the line tool in the shortcut menu and continue sketching. When I bring my cursor close to this endpoint, again a yellow flag will appear, letting me know that a geometric relation is going to be added. As we saw with the first line segment, this geometric relation is telling me that this endpoint of the line is going to be coincident with the endpoint of the first line we created. Make sure that the yellow flag appears, otherwise you might end up with small gaps. With the yellow flag showing, I'll click to start the line. Click again for the next endpoint, and notice that since the yellow horizontal flag was showing when I clicked the endpoint, a horizontal geometric relation was added. To keep this example simple, I'll sketch a few more line segments, making sure that the horizontal and vertical flags are appearing. On this segment, notice that the vertical flag is shown in yellow, but the horizontal flag is shown in white. What this means is that Solidworks is adding a geometric relation for vertical, but the white horizontal flag is really just for inference. This lets me know that the line segment is going to end horizontally, but it's not adding a geometric relation. Let me show you what I mean. I'll click to define the endpoint, and I'll press Escape to exit out of the line and finish this chain. So again, with the selection arrow, I can click and move geometry, and when I drag the line, you can see that it's locked to be vertical. But if I click the endpoint and move it, you can see that it's free to move. Even with the inference line appearing, Solidworks didn't actually add the geometric relationship. These automatic relationships that Solidworks creates while you are sketching are really just a convenient way to add relations, but I'll show you in a minute how you can add these at any time. To continue on with our example, I'll press the S key to bring up the shortcut toolbar and again activate the line. I'll snap on the endpoint of this line segment, and this time, I'll sketch a line off at an angle. Again, notice the inference line that lets me know that the segment is vertical with this other line segment, but since the sketch flag is shown in white, no automatic geometric relation will be created. I'll click for an endpoint, and this time, notice these yellow inference lines that appear. As I bring my cursor close to that yellow inference line, another yellow flag appears, letting me know that this segment will be perpendicular to the previous line. If you don't want the relationship to be added, make sure you just click slightly off. This can always be adjusted later. In this case, I'll go ahead and add that perpendicular relationship, so I'll make sure that the yellow flag appears. I'll continue sketching, and close the chain of lines on our first line segment. Let's take a look at some of the automatic relations that were created as I sketched. You saw how I added a perpendicular relationship, and if I highlight over the flag, you can see the two entities highlight, which have the perpendicular relation. If I click on the endpoint of the line, I can drag and move it anywhere, and you can see that Solidworks keeps that perpendicular relationship. If I click on this endpoint, you can see that I can move it side to side, but I can't move it up or down because of the horizontal geometric relationship that was added. So, let's talk about how to add a few more relationships manually. I pointed out how this endpoint here didn't add a geometric relationship. Only the white flag was present. But what do you do if you actually want this point to be exactly horizontal with this line segment? This can be accomplished by selecting two items manually. To do this, I'll first select the endpoint, hold down the Control key, and select this line segment. When I do, a pop-up window appears, showing the different options I have for the relationships that I can add. As a new user, it may be difficult to understand what all these icons mean. And of course, you can roll over them to see an explanation. But it sometimes may be easier to just take a look in the Property Manager to see what options you have. Notice that between this line segment and the point, Solidworks gave me a couple options of midpoint or coincident. Let me first press Escape to clear the selections. Now, instead of selecting the line segment and the endpoint, I'll select both endpoints. When I do, you can see some slightly different options appear in the Context toolbar as well as in the Property Manager. These options may appear different based on the geometry you select. In this case, I can make the 2 points horizontal. If you ever want to get rid of a relation, all you have to do is click on the flag and press Delete. In case you don't see these flags, you can always turn them on or off from the Heads Up toolbar under this Hide Show Items dropdown. I like to leave these on so that you know exactly what relationships have been added. Otherwise, it can be really difficult to tell what geometric relations you have, such as this perpendicular relation here. So, I'll turn this setting back on. Now that we've deleted this relationship, you can see that it's free to move again. Just to show you the other approach, I'll select the endpoint and the line segment instead of the endpoint. And again, Solidworks gives us the options that are possible between these two types of geometry. In this case, I'll use a coincident relation, which will make this endpoint coincident with this line. Geometric relations are just one of the ways you can fully define the sketch geometry. Next, let's take a look at dimensions, which will be used to fully define the rest of the shape of the part. Up to this point, we've created some basic geometry and added some geometric relationships. In order for the sketch to become fully defined and turn black, the next thing we have to do is add dimensions, which can really control the size of the part. When you add dimensions in SolidWorks, you'll be working with a tool called the Smart Dimension. This type of dimensioning feature is called a Smart Dimension because it takes care of adding the appropriate dimension based on the geometry you select. Let's start with this vertical dimension here. To add it, I can simply click on the line segment, and SolidWorks adds a distance dimension. Next, I'll click again to place it in the graphics area, and a spin box pops up letting me type in the desired length of the segment. I'll type in 50 millimeters, and I can press enter or click on the green check. When I do, notice that this sketch turned black up here. It's black because this line segment has a horizontal relation, and it's 50 millimeters above the origin. If I press the escape key on my keyboard, you can see that I cannot drag this anywhere. If you want to modify a dimension, all you have to do is double-click on it, and the same spin box appears. I can type in 75 millimeters, and the sketch updates. So the dimension is really what's being used to drive the shape of a part. Let's continue on and add the rest of our dimensions. I'll press the S key on the keyboard and access the Smart Dimension tool from here. With this first dimension, I clicked on the vertical line segment. However, you can really select any geometry, and SolidWorks will be able to create the dimension from that. You can also use points, or a combination of points and lines to create the dimension. In this case, I'll use a point-to-point dimension between these two endpoints, and SolidWorks creates the distance dimension. I'll click again to place it in the graphics area, type in 50 millimeters, and press enter. Next, let's add a height dimension here. Again, I can click on this vertical line segment, but to show you one other approach, I can click on this other horizontal line segment, and it switches to a vertical distance dimension. I'll click again to place it, and type 25 millimeters for the distance. As we do this, you can see more of the geometry turning black, which means it's fully defined. Keep an eye on the status bar down here. This lets you know that the sketch is still underdefined, meaning there's still blue geometry. We really want this to say fully defined before we move on and start creating 3D features. I'll continue by adding in a vertical dimension here. Notice when I do this, SolidWorks prompts me, telling me that there's a problem. The reason there's a problem is because this dimension would actually overdefine the sketch. I'll click cancel to show you why. Remember when we added this relationship here? This told us that the endpoint of this line was coincident with this horizontal line here. And these two height dimensions are actually driving the location of this line up here. So that means the length of this line is really being defined by these two dimensions and the fact that this endpoint is coincident with this horizontal line. Next, let's create the overall width of the part. I'll click on this vertical line segment and click here to give us our overall width. I'll type in 150 millimeters and press enter. At this point, a lot of the geometry is turning black, and it can sometimes be unclear what dimensions or relationships need to be added in order for the sketch to become fully defined. What I recommend in order to determine which dimensions and relationships to add is to simply click and drag the blue, underdefined geometry. I'll first press escape on the keyboard to get back to my selection arrow. With the selection arrow, I can click on any of the blue, underdefined geometry and see what's able to move. In the case of this line, I'm unable to move it. But if I click on the endpoint, you can see that it's possible to still move that. So you can see it's free to move side to side, and the other thing that changes is the angle of these lines. So that's a good cue to know what type of dimension to add next. Let's go ahead and add an angular dimension between these two lines. I'll press the S key to bring up the shortcut toolbar and start the Smart Dimension again. To add an angular dimension, all you have to do is select the two segments. And since we're using the Smart Dimension tool, SolidWorks automatically knows to switch this to be an angle. I'll click again to position the dimension and type in 135 degrees. When I do, this line segment turns black. But what needs to be defined still? Again, I'll press escape on the keyboard to get back to my selection arrow and click and move the geometry. You can see that if I drag the line segment, the geometry only moves in this direction. But if I click on an endpoint, it moves differently. So as a designer, it's up to you to decide how you want this part to behave. You can use a dimension, or perhaps you can use another relation. In this case, maybe we'll make this endpoint vertical with this line segment here. I'll select the endpoint, and I can either select the line segment or the point itself. I'll select the endpoint, and I can choose vertical from the context toolbar. Again, more sketch geometry turns black, with just a single blue line segment remaining. I'll again try to click and move any of the geometry, and I can see that I can only move it in this direction. It's always a good idea to try a combination of points and segments to see what you're able to move. In this case, it's pretty clear what dimension needs to be added, so I'll again launch the Smart Dimension tool, and I'll add a distance on this line segment here. Type in 100 millimeters and press enter. At this point, Solidworks tells me that the sketch is fully defined and all the geometry turns black. It's a good idea to pay attention to the status bar, because oftentimes you may have tiny line segments that may not be easily noticeable, even though they're actually blue. In this case, we know our sketch is fully defined, and we can move on to creating our 3D feature. Now that the sketch is fully defined, let's move on to create some 3D geometry. To do this, I'll be using the Extruded Boss Base feature, so I'll switch from the Sketch toolbar over to the Features. From here, I'll click on the Extruded Boss Base icon, and when I do, Solidworks rotates the graphics area slightly to give me a better view of the 3D space. In the Property Manager, there are a couple options that we will go over here. To give the extrude a desired thickness, I can either type in a value here or use the spin box. If I type in 15 millimeters and press enter, the preview will update. Also notice that there's a drag handle here. I can click on the handle to control the thickness. There's also a ruler that appears next to my pointer, and if I move my cursor close to that, you can see it actually snaps onto certain increments. The drag handle is kind of a convenient way to quickly see the 3D geometry, but most of the time, you'll be typing in a specific value here. Notice the direction the geometry is being added in. What if we want this geometry to be extruded in the other direction? Well, I can use the drag handle to drag it to the other side, but notice that there is a direction button here in the Property Manager. If I click it, I can reverse the direction from one side to the other. Right now, we're using what's called a blind extrude. Blind simply means you're typing in a value to extrude it in a single direction. I won't go over all the options here, but there are a couple I would like to point out. A very common option is midplane. When I select it, you can see that Solidworks takes care of splitting the thickness onto both sides of the sketch plane, which results in the sketch being in the center of the part. If I type in 10 millimeters, Solidworks is adding 5 millimeters on each side so that the total thickness is 10. At this point, I'll give the extrude a thickness of 30 millimeters and click OK. When I do, you can see the 3D feature is created, and the feature tree lists the first boss extrude. If I click the arrow next to this feature to expand it, you can see the sketch that was used to create it. At this point, we can continue adding features, but I'd like to show you how to work with some of the geometry you've already created. If you'd like to change some geometry, oftentimes new users tend to delete features and recreate them from scratch, but that's not necessary. In Solidworks, you can always go back to the sketch to change the shape of the geometry, or you can always go back to the feature to change the thickness. Let me show you what I mean. If you decided you wanted to change the shape of this geometry, remember, the shape is being controlled by the sketch. To make changes to it, all you have to do is select it in the feature tree and click Edit Sketch from the Context toolbar. This brings you back into Sketch mode, where you can modify any of the dimensions or relations. Let's change one of the dimensions. I'll double-click on it and make it 100 millimeters. When I do, the geometry updates. And if I click the Exit Sketch button, we return back to Edit Part mode, where you can see that the feature has been updated. I'll go back into the sketch once more. I'll click on it and again select Edit Sketch. Up to this point, I've skipped over this red X icon. The red X discards any changes that you make. So if I double-click and edit this dimension to, say, 150 millimeters, but later decide that I didn't mean to change this dimension and I really wanted to keep the geometry I had before, I can simply click the red X and select the Discard Any Changes and Exit option to have the geometry return back to what you had before. If you actually want to save a change that you make, you can first edit the sketch, make the desired change, and simply exit the sketch. So we've seen how to change the shape of the profile based on the sketch, but I'd also like to show you how you can always modify the thickness as well. The thickness is driven by the Boss Extrude feature. If I click on the feature, notice there's an icon in the Context toolbar to edit the feature. When I click Edit Feature, it brings us right back to the Property Manager we had earlier. So I can change the thickness here. Or if I want to, I could change it to be a blind extrude, and even flip the thickness to the other side. After making the change, I can click on the green check and the geometry updates. So, to sum up, the sketch is controlling the shape, while the feature is defining the thickness. Every part you create in SolidWorks will begin with a 2D sketch. In this example, I'll show you one method for creating this basic shape. I will use sketch tools, basic dimensions, and geometric relations to create a fully defined sketch. Let's get started. I'll begin by starting a new part file. Before I start sketching, I want to make sure the units are set to inches. I'll go to Options, Document Properties, Units, and select IPS. Next, I'll create a new sketch on the front plane by going to the Feature Manager design tree, clicking once on the front plane, and selecting the new sketch icon from the pop-up menu. I will use the line tool, which is found in the sketch toolbar, to create a chain of lines to form the basic shape of the sketch profile. I'll begin the line so that the first endpoint is coincident with the origin. As I continue, take note of SolidWorks' ability to create automatic dimensions and geometric relations. First, notice the number that appears next to the cursor. This value lets me know the approximate length of the line I am sketching. Next, notice that when I bring the cursor up close to vertical, a yellow flag appears next to the cursor, indicating that SolidWorks is going to automatically add a geometric relation. I will continue to form the sketch profile, making sure I use the same vertical and horizontal geometric relations as stated in the example problem. Notice that the sketch is black and blue. Black geometry indicates that it is fully defined, while anything blue is underdefined. It's generally considered best practice to fully define all of your sketches, and in fact is one of the goals of this exercise. To do this, I can launch the Smart Dimension tool either from the sketch toolbar or by pressing the S key on the keyboard, which brings up a shortcut menu where I can select it as well. The sketch is complete once all the segment geometry turns black. SolidWorks also lets me know the sketch is fully defined by the status bar at the bottom of the screen. If there is underdefined geometry, a good way to troubleshoot this is to click and drag on any points or line segments that still appear blue to see how they are able to move, and then add the appropriate dimension or relation. As with any design in SolidWorks, there are often a lot of approaches that will lead to the same end result. Even a simple design like you see here could be accomplished with a variety of approaches, but I will walk you through just one of the ways here. Regardless of the approach, one of the goals here is to fully define any sketches, and we are also looking to have the part match the orientation you see here in this isometric view. Let's get started. I'll begin by opening a new part file. Before I start a new sketch, I'll make sure the units are set to the millimeter gram second standard by going to Options, Document Properties, and selecting Units, or by going to the status bar and clicking this button here. The first step here is to begin a sketch for the Extrude feature. But what plane should I begin the sketch on? In this case, I will choose the right plane because I plan on sketching the tombstone shape that will make up the overall profile, so that when I extrude it, the end result will match the orientation I showed you at the beginning of the lesson in the isometric view. I will select the line tool and begin the first endpoint on the origin. When I get to the top right corner of the sketch, the next thing I will need here is an arc. Feel free to play around with the various arc tools on the sketch toolbar, but since this arc will be tangent to this endpoint here, I prefer to use auto transition. To do this, I simply bring my cursor back to the endpoint of the line, and when I move the cursor away, SolidWorks automatically transitions to the tangent arc. I'll pay close attention to the blue inference lines that appear before I place the other endpoint of the arc, so that it aligns with the first endpoint as well as the origin of the part. As soon as I click the second endpoint, SolidWorks returns back to the line tool. I'll finish the sketch profile by placing the last endpoint on the origin. Next, I'll add a couple of dimensions to fully define the sketch. To create 3D geometry, I'll switch over to the Features toolbar and select Extruded Boss Base. The Boss Extrude property manager appears. I'll set the end condition to blind and type in 10 millimeters for the thickness and click OK. At this point, the part is complete, but did it meet all of the criteria? I'll press the spacebar on the keyboard and switch to an isometric view. As you can see, the orientation of the part matches the orientation of the original view shown in the example. Finally, I want to double-check that everything in the part is fully defined. I can double-check this by expanding the feature in the tree to reveal the sketch. If there is a minus sign in front of the sketch here in the tree, that means the sketch is not fully defined. To fix it, just edit the sketch and look for any geometry that is blue. As you can see, the sketch is fully defined, so the part is complete. One more thing I'd like to mention is that if you'd like to give your model real-world properties such as a mass and density, you should set a material. To set the material for this part, I'll right-click on Material in the Feature Manager tree and select Edit Material. I'll go into more detail about the type of materials available and how to create a custom material at a later time. But for now, I'll browse to plain carbon steel, click Apply, and close the dialog box. You can see that plain carbon steel is now listed in the Feature Manager tree. Now if I go to the Evaluate toolbar and select the Mass Properties icon, you can see the mass of the part listed here, along with other properties of the part. As a designer, there will often be times where you have to edit a design in which you are not the one who originally created it. In cases like this, it is important to be able to identify whether you need to edit sketch profiles or 3D features in the Feature Manager tree to make the changes that are required. In this example, I will be changing the profile shape as well as the thickness of the part. I'll begin by changing the profile shape of the design by editing the sketch. To do this, I'll click on the Boss Extrude feature and select Edit Sketch from the pop-up. I'll double-click on the dimensions I want to change. I'll change the width to 350 millimeters and the radius to 80 millimeters. Once I'm done, I'll click OK and return to Edit Part mode by clicking the Exit Sketch icon in the confirmation corner. Next, I'll edit the overall thickness of the part. The thickness is controlled by the Boss Extrude feature. I'll click on the feature and select Edit Feature. In the Property Manager, I'll change the thickness to 150 millimeters and click OK. Finally, I want to change the height of the part, but this time, I'll use a shortcut method to accomplish this. I'll double-click anywhere on the Extrude feature in the graphics area to display all of its associated dimensions, which include sketch dimensions as well as the feature dimensions. I'll double-click on the 150 millimeter height dimension and change the value to 200 millimeters. I'll click on the Rebuild icon to update the part. To make sure I've done this correctly, I will check the mass of the part by clicking the Evaluate tab of the Command Manager and selecting Mass Properties. If the Evaluate toolbar does not appear, right-click anywhere on the Command Manager and select Evaluate. Alternatively, you can open the Mass Properties from the Tools drop-down menu at the top of the SolidWorks interface. The mass should come out to be 62,650 grams. If the mass value does not match exactly, go to Options, use Custom Settings, and change the decimal places. I'll select 0 and press OK. If the mass is still incorrect, double-check the part, making sure it is using metric units and the material is set to plain carbon steel.